Hey, welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to talk about matrix operations. So we're going to start with naming a matrix. So you're going to name it by like rows, which are horizontal, and then columns, which are vertical. So we name it row by column. So the amount of rows times the amount of columns. So here, A, B, C, D, E, F, we have one row, two rows. So this is 2 times how many columns? 1, 2, 3. So this is a 2 by 3 matrix. Now this, we have 1, 2, 3 rows, but there's only one column. So you get it? So this one, there's only one row, but there's 3 columns. So it's a 3 by, no, sorry. Yeah, that's a 1 by 3. 1 by 3. Okay, now to add and subtract matrices, you're going to say, okay, they have to be identical. Like you can add a 2 by 2 matrix to a 2 by 2 matrix, a 3 by 1 to a 3 by 1, a 1 by 3 to a 1 by 3, a 24 by 1 to a 24 by 1. They just have to be the same ratio. So make sure you like find that out. Okay, so, and then all you do there is you combine the like positions. So first, let's name these two and see if they're the same. There is one row and 2 columns. So this is a 1 by 2. And then there's one row, 2 columns. So this is a 1 by 2. So yes, we can add these two together. Now, like I said, you just combine the like positions. So this is 8 plus negative 2 would be 8 minus 2 would give us 6. This would be 9 plus 1 would give us 10. So we get the matrix 6, 10. Simple, right? Then there's something called scalar multiplication. Remember, you can multiply any row of a matrix by any number. So you can do that same thing, just multiply any matrix by any number. Again, we're using a 1 by 2 and a 1 by 2. But this can be done with like a 3 by 3. You can just go up. All you need to do is just multiply every number in the matrix by the scalar and then do whatever operation it says. So here we have the scalar of 2 for the matrix 4, 2, and then the scalar negative 3 for 1, 2. Okay, so this would be 8 and 4 minus 3 and 6. So this would be 8 minus 3, right? Because we're doing like positions. So 8 minus 3 is 5. This would be 4 minus 6, which would be negative 2. Okay, so that's scalar multiplication. Now let's go on to real multiplication, where it gets a little more difficult. This one's a little difficult to just understand how it works, so hopefully you guys get it. Okay, so to multiply, your matrices have to be m by n times n by p. And what that means is that these middle values here have to be the same. Like this is a 3 by 1 times like a 1 by 3, right? Or a 1 by 2. It doesn't matter. They just have to be the same in the middle. And then your resulting matrix would be an m by p. So if it's a 2 by 2 times a 2 by 3, right? You'd be like, oh, there goes the 2 in the middle is going to be a 2 by 3. Okay, so we're going to test this here by finding AB, BA, and let's do A squared. All right, so A is negative 4, negative 1, then 2, 12, and B is negative 6, 5. Okay, so this is a 1, 2, 2 by 1, 2. A 2 by 2 matrix, and B is a 1, 2 by 1. So a 2 by 1 matrix. All right, so if we were to find A, B, we would get 2 by 2 times 2 by 1, which clearly there's 2's in the middle, so we're good, and that would result in a 2 by 1 matrix. Okay, so we make this. Remember, there's going to be 2 columns, and there's going to be 2 rows, and there's going to be 1 column. All right, so what we do here is we say this is row 1, column 1, right? Because you're just labeling it. It's row 1, column 1, and then this is row 2, column 1. So we're just labeling them. Now what you do is you go to A and you multiply all of row 1 times the column 1 of B. So row 1 would be negative 4 times negative 6, would be 24, right? Then you go over 1. You'll do negative 1 and 5. So you just scoot over. So negative 1 times 5 is negative 5. And you add those together, and we will get like 19 or something like that. Then we have row 2 times column 1. So we just go down to this row here and multiply it by this column again. So we do first position, then second position together. So 2 times negative 6 is negative 12. And then 12 times 5 is 60 or something. 60, and then that equals 48, I believe. So if we want to like show that again, it's just 9 and then 48. And that is a resulting 2 by 1 matrix. So that is a B equals. Okay, now let's try to block that off. Or I could just erase it, like I probably should. Okay, so now we're going to do BA. All right, so BA equals, well, B is a 2 by 1. We're going to say, okay, 2 by 1 times a 2 by 2. Right? Well, this 1 and 2, they are not the same. So we cannot multiply those. So you say like no solution. Right? You just cannot multiply those two because the middles are not the same. So you can't come up with a matrix from that. Okay? So now we can do a squared. Okay? A squared equals a 2 by 2 times a 2 by 2. But if you were to do something times like b squared, you get a 2 by 1 times a 2 by 1, which that 1 and 2 would not work. So you couldn't square b. But here, a squared works out very nice. We're saying, okay, these two in the center are good, so we can multiply them, and then we would result with a 2 by 2 matrix. All right, well, let's do the little 2 by 2. I don't want to give it too much room because I don't know how big this is going to be. Okay, so this would be row 1, column 1. It's good to label these. And then like over here, I always give so much room. This would be row 1, column 2, because it's still row 1, column 2. And it's a 2 by 2, so we only go 2 columns over. And then this would be row 2, column 1, row 2, column 2. All right, so what this means, again, is you multiply row 1 of, like, A times column 1 of A. And you use, like, first position, second position. Okay, so this would be row 1, first position's negative 4, and column 1, first position, is negative 4. So we would get negative 4 times negative 4 is 16. Then row 1, like, position 2, times column 1, position 2, would be negative 1 and 2. So that would be minus 2. That gives us 14. All right, now move on. Row 1, column 2. Well, this is negative 4 times negative 1 gives us 4. Then, like, move positions, it would be negative 1 and 12. It would be minus 12 gives us negative 8. Then, if we go row 2, column 1, we have 2 times negative 4, which would be negative 8, I believe. And then we'd have 12 times 2 would give us 24 equals that 16. Yeah, it's weird when you do it with the squares. There's so many ways to make mistakes, and if I made a mistake, I'm sorry. Row 2, column 2. So we go, okay, row 2, column 2. 2 times negative 1 is negative 2. And then this would be like position 2 for column 1, well, for column 2 and row 2. So 12 times 12 is 144, and that equals 142. So we put that in a new little box. That all this work, and it's 14, 8, 16, 142. And that is a squared. So rather than what you might think, where it's like, oh, you just square all the values, right? And you'd be like, okay, well, negative 4 squared is 16. That's 1. That's 4. That's 144. No, you don't. It's like squaring like a plus b, right? If you do a plus b and you square it, some people would be like, okay, that's a squared plus b squared, right? Simple. But no, you really have to say, oh, that's a plus b times a plus b, and you'll get a squared plus 2ab plus b squared, right? So you don't just say, okay, the squared distribute. No, when it's something like this or something like this, you actually have to multiply it by itself and go through the steps. First of all, make sure that you can multiply, because if it's something like a 2 by 1 times a 2 by 1, you're not going to get anywhere with that, and your answer will most definitely be wrong because there's not even going to be a solution to it. Okay, well, I hope this video was so helpful. Comment anything if you want. Say hi. I really appreciate it. Let me know that you finished the video because I don't think most people do. Please like and subscribe if it was helpful, and thanks for watching.